Okay, so we were studying the electromagnetic induction, that is how to induce current. Okay, so we were studying electromagnetic induction. That is a clear thing. Okay, and we are inducing current. Okay, so by this magnet, okay, by this magnet, as this magnet will come closer to this coil, okay, this coil will also face, this coil will also face the power, or we can say the coil will also face the magnetic field lines. And this coil, okay, this is the coil, and if the magnet is very much close, okay, so this coil will also feel the magnetic field lines, and the current, okay, will flow into them, the current will flow into them. Okay, and according to the direction of the current, okay, the needle of galvanometer get deflected either in this direction or either in this direction. And if something is stationary, it will reach to zero. So the deflection of the needle of galvanometer, only the deflection occurs when there is movement, either the uh, uh, magnet will go to this side, or either the magnet will go to this side. Okay, there will be the deflection. And if it is stationary, okay, then the needle of galvanometer comes to zero. So in this case, okay, uh, if you bring this so much close, okay, or so much close, or we can say that if there is a limit, okay, if there is a limit of this magnet, and though it is very far, but it has magnetic field lines, so the effect of these magnetic field lines, with the effect of these magnetic field lines, okay, this coil will also face, this coil will definitely, this coil will also face the effect of these magnetic field lines, and that is the flow of electricity. Okay, so that is the flow of electricity, that is the flow of electricity. So this is the flow of electricity in magnet. Okay, flow of electricity in magnet by this method. Okay, now Faizan asked me question that what happen if we change the poles. This is coil and this is our galvanometer. Okay, so you asked me that what happen when we change the poles. This was north pole and this was south pole, and what happen if I change the four poles, if I bring south pole here and if I bring north pole here. Okay, so in case of north pole, okay, as current will only flow when the this coil will come in contact with these magnetic field lines. Okay, so it will come in contact with this magnetic field line only when the current will flow. And as the current will flow, as the current will flow, the needle of galvanometer get deflected to this side. Okay, so if we are moving close, if I'm moving this closer, the needle of galvanometer deflected to this side, and if we are moving this apart, the needle of galvanometer will get deflected to this side. Okay, now what for this case? In this case, okay, in this case, okay, so in this case, okay, when we move it closer, definitely the magnetic field lines will, okay, these are the magnetic field lines, okay, north to south. So definitely there will be the deflection, but the deflection will be just opposite. When you are closing, when you are making them closer, the galvanometer needle will get deflected, but now it will be in this direction. Okay, and if it is moving apart, you are making this magnet and this coil apart, then the deflection is in this direction. Okay, so in both cases, if this is north pole and this is south pole, okay, so if you are making them close, okay, the direction of needle will here in this case, okay, the direction of, and the direction of needle will this in this case. And if you are making them apart, okay, if you are making them apart, so the direction of galvanometer will in this direction, and here the direction of galvanometer in this direction. So you can see the two directional difference. Other than there will be no difference, everything will be the same. Okay, only because there is change on the current, the change in direction of flow of current, change in the direction of flow, okay, of current. Okay, so what happens actually, the thing we are learning, that what happens actually. So the real thing is, the deflection is very real thing, okay, and as it is deflected, there is definitely there is presence of current, because galvanometer, on last class we studied that this was our galvanometer, and it identifies the change in current. It identifies change in current. Okay, so the current will change only if there is current. Okay, now sometime it fluctuate here and sometime it fluctuate here, but it will change the needle will change its direction only if there is current. So definitely there is a presence of current due to this magnetic field line. Due to this magnetic field lines, okay, the current will flow here, and same thing due to this magnetic field lines, due to effect of these magnetic field lines, okay, the current will start flowing also in this. Okay, also in this. Okay, so now current is flowing here. Okay, and if you change the direction, okay, now the current is flowing is in this direction, and if you change the side, you bring south pole here and north pole here, then the flow of direction of current is in this direction, definitely current will flow. So in this direction, what is flowing here? A current is flowing. And what is current? Electric current is flowing. So we were studying induction. We were studying induction. Okay, we were studying electromagnetic induction. Okay, so in this case, okay, we studied that two things will be given. One thing will be magnetic field lines. So these are our magnetic field lines. And second thing will be given to us, that will be force. Okay, so here definitely we are not going to learn about force, because this rule is applicable for generator. Okay, and third thing, that induced. Okay, the third thing that is induced, or that is created, or that is produced. What produced? Electricity is produced. Okay, because electricity is flowing. Okay, electric current is flowing. This coil is electric coil. Okay, now this coil has electricity in this. It has electricity, and this electricity is generated only because of this magnet. So when this magnet is come in close, or it will go apart, okay, there is a generation of electric current. Okay, there is change in direction. Sometimes it will go to here, or sometimes the flow current will go to here, but that is definitely induction. We induced something, we created something, we produced something, that is electricity. So Michael Faraday thought that each and everyone, at that time, each and everyone is creating magnet from electricity. Okay, and Michael Faraday was the one person who thought that, can I make electricity from magnet? He thought that, and he proved that he did that. That what he did, that he bring these two things very closer and bring these two things very apart. First one is magnet and second one is that coil. And finally, due to impact of these magnetic field and due to power of these magnetic field lines, the conductor also allows, or also passes the current. So what are these current lines, or what is this electricity? Actually this current is actually the magnetic field lines. So this magnetic field lines are actually current. Okay, these magnetic field lines are actually, they are current. Okay, they are current lines. But here we cannot say they are current, they are magnetic field lines when we consider from a magnet. But when we put these two things very close, and this is a metal thing. Okay, this is a metal wire, we can say this is a copper wire. So these current will flow into this copper wire or this metal wire, and these will flow the current, or the process of current, the passage of current. Okay, so this is how the electricity is induced, and this is how the electricity is produced. Okay, so what is the use of these things in our daily life? What is the use? Okay, why we are doing this much stuff, and why we are doing this type of experiment? So by using this method, by using this method, okay, what is the method? That one, we are using magnet, and second, we are using the this is solenoid. Okay, you can use any type of your ring. Okay, you can use this. So this is solenoid. Okay, so there are two cases. Either you can put this magnet closer or away, either you can put this coil closer or away. You can take both of them closer or away. Both things are possible. Okay, not only magnet, but if this magnet is stationary and you will move this, the results will be the same. Okay, if the magnet is stationary, okay, and this coil is moving, okay, coming closer and moving apart, this thing is possible. Second thing, you can also move this magnet, so this magnet can be movable and this can be stationary. Okay, second thing you can do, you can make stationary this magnet, and you can move this coil. And in third case, you can move both of them. Okay, you can move both of them, you can move. So either one of them, either the coil should be in movable condition, or either the magnet should be in movable condition. Okay, okay, but there is only one condition which is impossible, that when both of them are stationary. Okay, when both of them are stationary. Okay, if both of them are stationary, then there will be no induction and there will be no change in the needle of galvanometer. So both of them, either you can move one thing, either you can move two things, okay, or you can move both. Okay, you can move this, you can move this, okay, or you can move both of them, but you cannot put both of them stationary, otherwise there will be no induction of current. So we induce the current. Okay, now what is the use of this thing? Okay, just what are we doing? We are just taking this a coil, and this is our galvanometer, and this is our magnet, and what are we doing? We just moving one, or moving two, or moving both of them. Okay, so what is the use of this thing? Is why we are doing this? This is not a game. Okay, just we are doing this and we are moving the needle of galvanometer, and we are seeing that galvanometer is needle is something sometimes here, and when we put this apart, the needle changes. So what, why we are doing this? Okay, and what is the use of all these things? That are we gaming something, or are we doing a game by this? No, this is of very much importance. What is the importance? That by this method you can give electricity to a huge building. You can give electricity to a huge building. Yes. Okay, why? This is a magnet. Okay, and by the impact of this magnet, okay, by the impact of this magnet, okay, the electricity will pass to here. Okay, this is my magnet. Okay, and now in this case you don't have to you don't have to work so much about the direction of current. Okay, that is not so important in this case. Okay, so this is magnetic field lines, and due to impact of these magnetic field lines, okay, due to impact of these magnetic field lines, there is a conduction, there is a conduction. Okay, so this wire is having electricity. Okay, this wire is having electricity, because magnetic field lines are actually electric lines. Okay, they are electric lines. Okay, so if I use this, okay, this is a magnet. Okay, and by use of this magnet, I have conducted electricity, I have flowed the electricity. And if I join something here, if I join something here, what I'm joining? If I join some bulb here, okay, or if I join some TV or tube light here, it will get electricity and this bulb will glow, or it will illuminate. Okay, so in this circuit, okay, in this circuit, when this circuit is getting electricity, when this circuit is getting electricity, you can remove galvanometer, because there is not need of galvanometer. Okay, you can use anything here. You can use a bulb, or you can use a TV or refrigerator, whatever you want. Okay, galvanometer just for our knowledge that current is flowing or not, that's it. Okay, but other than this, there is no use of galvanometer. Okay, so just by using a magnet, okay, just by using a magnet, just moving this magnet apart, or just moving this magnet close, or just moving this coil apart, or just moving this coil close, or if we are moving both of them close or both of them apart simultaneously, okay, just move them. Okay, don't make them stationary, you have to move them. Okay, so I can grow a bulb, I can uh, manage my TV, and I can manage my refrigerator just by this magnet. Isn't it useful? That by a single magnet, okay, the power of magnet is determined by its size. So if it is a huge magnet, you can work with so many electric appliances like TV, fridge, fan, geyser, cooler, washing machine, just by a magnet, that you are moving them and the current is flowing. Okay, you one need is don't make them stationary. Okay, just move them close and apart. Okay, just move them close and apart. Okay, so there will be electricity, and by this electricity I can use this electricity for so many appliances. So isn't it useful? This is not just a game. Okay, just moving something close and making moving apart, this is not just a game. This is a very useful thing, that by a magnet I'm creating electricity. You can do it by your own. Okay, you can do it by your own. If you have magnet, just make this solenoid. Okay, and you can do it by your own. Okay, so now what is this thing? This is an electromagnet. What is this thing? This is an electromagnet. These are copper wire. Okay, and this is our battery. So we know that this is our electromagnet. Okay, this is electromagnet. This is not a simple magnet, normal magnet. This is electromagnet. Because what are the advantages of electromagnet over a simple magnet? Okay, this is a simple magnet and this is electromagnet. Okay, simple magnets are, if you want to make a huge impact, or if you want to make so much magnetic field lines, you have to use a very 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 large magnet. Okay, so it is very heavy and it is not a used to thing, you cannot carry it easily. Okay, so it is very, you need a very large amount of magnet, natural magnet, to work with it. But for electromagnet you need just some centimeters of wire and it will work at a huge magnet. Okay, it will work as a magnet, just pass the current, just pass the current. So it is a electromagnet, but definitely it is giving the effect of magnet. What effect? South pole, north pole magnetic field lines. And this is a simple magnet, definitely it is a giving effect of magnet, that south pole, north pole magnetic field lines. But it is very huge and difficult to carry, and we cannot manage with this. If I need a huge magnetic field lines, I have to carry some magnet which is in meters. Okay, 5 meter long magnet and 10 meter long magnet. But here I just have, I can manage it. Okay, it is very heavy same time. Okay, difficult to manage, but it is very simple. I just need some coils and it will convert into electromagnet. So despite of using a simple magnet, okay, this is simple magnet, uh we can use this electromagnet because the size will be lesser and there will be less management, and it is very simple and less heavy thing, lighter thing. So in this case, okay, this is my electromagnet and it is giving same effect as magnet. So I'm writing this magnet. Okay, this is a magnet. So this is a magnet and this is another coil. Okay, so just consider that this is my coil. Just consider that this is my coil and this is my magnet. Okay, this is my magnet and this is my coil, and here this is my magnet and this is my coil. Okay, so if I move this coil near to it, or if I move this apart to this, okay, I can do same thing with this. Either I should move this close to this coil 1, or either coil 1, but definitely it is a magnet. Okay, it is electromagnet, and I can also move this apart, or I can move both of them close and I can move both of them apart. Okay, but you have to be in motion. Okay, so what happened, that by moving, okay, it has the electromagnetic field, definitely it has a electromagnetic field, and by the impact of this electromagnetic field, the coil number 2 will also get the will also come in the contact of this electromagnetic field, and it will conduct electricity. What will it do? It will also conduct electricity, same like this. Okay, this is a magnet, and by this electromagnetic field lines, okay, it will start conducting electricity. It will also start conducting electricity. Okay, and if it is start conducting electricity, okay, so there is electricity. Now what is the use of these diagram? There should be question in your mind, that what is the meaning of these diagram, that I'm giving a current and I'm obtaining up, I am giving a current, I'm making this electromagnet, and I'm obtaining a current here. What is the use of this? Can't I get current directly from here? So if it was okay if I was using a magnet and if I'm getting a current, it was okay. Okay, good idea, intelligent idea, that I am obtaining electricity from magnet. But what is the use of this? Isn't it rubbish thing that I'm giving electricity? First of all, I'm giving electricity, I'm doing so much stuff like moving them apart, and finally I'm getting electricity here. Now what is the use of this? Can you tell me what is the use of this? Okay, I'm giving electricity and I'm obtaining electricity. What is the use of this? This is a useless thing and time consuming thing and unnecessary stuffs and unnecessary coils and moving. And this is a good idea, but you know, sometimes we cannot deal with this much heavier things, because if I want to manage or if I want to generate much amount of electricity, I have to use a very, very huge amount of magnet here. Okay, here I'm just using a simple, very small, tiny amounts of this electromagnet. Okay, can you tell me what is the use of this thing? What is the use of this apparatus if I'm using this? Can you tell me? Do you have any idea? Something which is clicking in your mind, that what is the use? Are we doing something rubbish because our book is provided with this diagram? Okay, this diagram is from NCERT directly. Okay, this diagram is from NCERT directly. Okay, now what is the use of this? Isn't it rubbish thing? Do you think it is rubbish? It is something rubbish, that providing electricity and making it electromagnet, and it will develop its electromagnetic field, and this electromagnetic field will impact this coil number 2, because coil number 1 is actually electromagnet. Okay, please tell me what is in your mind, and by the impact of this it will generating a current. Do you have anything in your mind? Do you have any idea? Yeah, very good. Saleh, give me the answer. Faizan, do you have any idea what is the meaning giving electricity from here and getting electricity from here? Now, what is the meaning of making this electromagnet? What is the use of this thing? Don't you have any idea, anything which clicked in your mind? Okay, let me tell you. Yeah, we can transfer electricity. Now, let me tell you. First of all, in my first thing, I told you, yeah, I told you that this thing is small, this tiny setup can give electricity to buildings. Okay, this tiny setup can give electricity to buildings. Okay, so this is, I'm not using a magnet, because you know, a magnet, if I use want to make a huge amount of electric current, I have to use a magnet which should be in meters, so I cannot deal with a 2 meter or 5 meter long normal magnet. So I just made this. Okay, I just made very simple thing. And this is a magnet now. Okay, electromagnet, but this is a magnet. Okay, now this is my magnet, and I can use this one. Okay, I can use this one. Okay, I can use this one. Okay, I can use this one. I can use this one. Okay, so don't forget that this is magnet because it is having this current flow. Okay, and all others are normal conductors or normal coils, and this is our electromagnet or magnet. Okay, so can't I move all of them, or if I make them stationary, if I just move this one? Okay, I'm just moving this one, it will release impact on this one. It will release impact on this one, it will release impact on this one, it will release impact on this one, and it will release impact on this one. Okay, so there will be a impact. Okay, I used 5 coils, I can use 6 coil, I can use 7 coil, I can use 100 coils, I can use 1,000 coils. Okay, so what I'm doing one thing, just to put it in between, put it between. Okay, this is magnet. Okay, put between, and you can use several coils around it, you can use several coils around it, and these so many you can use a number of coils. Okay, okay, and I'm using 5 because it is very difficult to draw sometimes. Okay, and time consuming, so I'm just moving this. Okay, I'm just moving this, I'm moving just this single one. Okay, you can move all of them, but I'm just moving this single one away and close, away and close. Okay, So by this moving, what we studied, that this is was our thing, that by moving them, okay, either you can move one or either you can move both of them. Okay, by moving this we can create a current. So all of them, okay, all of them, this one, this one, this one, this one, this one, all of them will face or will find out some electric current in them because of these magnetic field lines. Definitely it is a setup, and any random person cannot do this, but by these electromagnetic field lines created by this, okay, by this, okay. So this electromagnetic field lines will impact all of them, okay, and there will be conduction of current, there will be conduction of current. Okay, I'm drawing arrow, nothing extra. Okay, all of them will feel the direct flow of electric current, and you can generate, either you can generate bulb by this, because it is a current. Okay, it is a current. Simple thing, that what is this blue line indicate? This blue line indicates that I'm flowing, these blue arrows indicates that I'm flowing a current. Okay, there is a current, there is a current. Okay, so you can flow current, and by this current you can generate or you can illuminate so many things, whatever you want. Okay, so this is the use of these electromagnetic induction, that first we induce electricity, and you can use anything by this. You can put anything, you can put a bulb here, or you can put a TV here, or you can put a refrigerator here, or whatever you want you can put. So by this a single coil, by this single thing, okay, you can give electricity to huge building. Okay, so this is what we studied, how we can generate a current. And nowadays so many countries are using this type of induction. Okay, so by using this tiny amount of electricity you can use a huge amount of electricity. Okay, this is our diagram. Okay, uh, this is a diagram I take from somewhere else. And what this diagram indicates, this diagram indicates that this is our electromagnet. Okay, this is our electromagnet. Okay, and this is our galvanometer. Okay, and you can see how magnetic field lines impact. Okay, so you don't have to dig in, or you don't have to understand that much, that what is the direction of magnetic field lines here and what will be the south and north pole here. You just have to learn about that, the fluctuation of galvanometer field line. So definitely it is inside. Okay, how magnetic field lines flow inside, it will flow from south to north inside. So definitely it will be south pole, and definitely it will be the north pole. It will be the south pole and it will be the north pole. It will be the south pole and it will be the north pole. Okay, these two, because inside the magnetic field lines it will go from south to north, and outside it go north to south. So this is our induction. Okay, uh, now I this question, this chapter is completed, and rest of the part, that is generator and household current. Okay, which I'm not going to tell you, because our board has deleted these parts, and this is of no use for this year. Okay, so now we have a question. Okay, we have a question. What is the question? That explain different ways to induce current in a coil. Explain different ways to induce current in a coil. Okay, how can you induce a current? Okay, so we have three methods. We have three methods. Okay, either move this coil, this okay, I draw something wrong. I draw something wrong. Okay, now this is my magnet. and this is my coil. Okay, so by three ways I can conduct electricity to this. By three ways, I have three ways. Either I should move this, okay, first way. Okay, either you should move electromagnet or magnet. Second, either you should move coil. Okay, and the third thing is either you should move both of them. Okay, you can move close and apart both of them. Okay, the only method which is discarded, that if both of them are stationary. Okay, this is stationary and this is stationary, then this is the only thing when there will be no conduction. Okay, there will be no conduction. Okay, so stationary thing doesn't work. Okay, so you have to move this. So the current will pass only, the current will pass, or the magnetic thing will sorry, the current will pass. Okay, and current will generate only. Okay, the current will generate only, the current will generate only when you will do something higher to lower. Okay, or something lower to higher. Okay, what does it mean? It means that, okay, and I'm using a simple magnet. Okay, so either you are making, you have to do this change. Okay, either you have to do something higher to lower, or either you have to do something lower to higher. Only you have to do something change which is only possible by possible with the movement. So the change will induce current. Only the change will induce current. Okay, so I'm increasing something, I'm increasing the amount of current. If I'm making them close, I'm increasing the amount of current, because how much they are closer, there will be the more impact of magnetic field lines. Okay, so I'm increasing something, or I am decreasing something when I'm moving them apart. So I'm decreasing the amount of current, definitely. Okay, but the induced current, the current will only flow, the galvanometer show the amount of current only when there is a change. Okay, it should be changeable, you have to move them continuously. Okay, in three cases, either move this one, either move this one, or either move both. They should not be in stationary position. So move them, you have to move them either in this direction or either in this direction, whatever you want, but you have to move them to create the magnetic field line. So remember that change is needed to induce current. Remember this, don't forget that either you are decreasing or either you are increasing a current, but change is needed. Okay, so our chapter is finished, and 4 to 5 minutes are left, so I'm not starting a new chapter. Okay, now tell me,